This short video has been prepared to assist food and drink manufacturers to identify basic energy-saving opportunities relating to heat generation and distribution. To prevent excessive fuel consumption, heating systems must be well maintained and serviced. Any problems with the system can be relatively simple to detect and correct, and provide immediate and fast payback savings. The boiler must be regularly serviced and maintained. This is to ensure that it is operating at its optimum efficiency. A boiler service should be undertaken every 6 months. Make sure that the service includes the checking and resetting combustion efficiency. It is often worth witnessing this. Operating the boiler at optimum efficiency will typically save 3% fuel costs. Steam leaks occur regularly because of the aggressive nature of steam. These leaks need to be repaired as soon as practically possible, as they are a waste of energy and a possible health and safety issue. Steam leaking through a 1.5mm diameter hole can cost £750 per year in additional fuel. The cost of repairing steam leaks will invariably pay back in a few months. Not only is this closed automatic steam flow valve not insulated, but steam could be heard passing through the valve. The valve seal needs repairing or replacing. A union joint fitting has a small leak as shown by a droplet of water. This leak can only get worse and result in significant energy waste. It is simple to repair at this stage. Regular inspections should be undertaken to ensure that the pressure relief valves are not leaking steam. All pipework in your heat distribution system, including valves and flanges, should be insulated. By checking insulation regularly and taking corrective action, you can typically save 2% on your energy costs. The surface temperature of steam pipe and fittings that are not insulated can be over 140 degrees centigrade. A 10 metre 25mm pipe that is not insulated could result in an extra £450 of fuel per year being wasted. Savings from the steam pipework insulation typically repay the costs in 6 months. Steam or hot water pipework and fittings should be insulated to prevent energy from being wasted. The main isolating valves on and around the steam boiler are large and invariably not insulated. A valve can waste the same amount of energy as 1 metre of pipe. After repairs or modifications have been undertaken to steam or hot water pipes, it is important to replace the thermal insulation. Steam traps are vital for the correct operation of a steam heating system. They are subject to aggressive steam and require regular checking. If they become clogged or fail closed, then heat delivery will be reduced and it will result in excessive cooking or baking times. If they fail open, then costly live steam will be vented through the condensate system to the hot well and be wasted venting to atmosphere. Always act to repair steam traps if a steam plume vents from the boiler house. The cost of repairing steam traps is likely to achieve payback in months. A good steam trap maintenance schedule is likely to save 10% fuel savings in a food factory. A steam float trap and associated fittings shown in this picture are not insulated and was found to be passing steam to the hot well. The hot well tank stores returned condensate from the site. This is hot water that will be returned to the boiler system for steam generation. The water in the hot well should be as hot as possible, typically over 80 degrees centigrade. This picture shows that the side wall of the hot well has not been insulated after repairs were undertaken to stop a leak. To summarise the energy-saving measures, check boilers are serviced regularly and that combustion efficiency is checked and reset. Insulate all heat distribution pipes and fittings. Ensure leaks are repaired as soon as possible. Repair valves and steam traps that are passing steam. Conduct regular visual inspection of the heat distribution system. Consider using a thermal image camera to locate sources of heat losses. Ensure that the heat distribution systems and generation plant are kept separate from other plant, such as compressor-driven refrigerated chiller systems and compressed air generation plant.